Google Cloud Networking and Load Balancing Outage, a DevOps Postmortem. It's 9:30 U.S. Pacific on November 12, 2021. For most of the world, it's the dead of night, but for the engineers watching the dashboards, the alarms just started screaming. Suddenly, the front lines of the internet began to buckle. Across Europe, the digital infrastructure was hemorrhaging. Websites were vanishing into 404 errors, and critical services like Cloud Spanner and Bigtable were grinding to a halt. This wasn't a localized glitch, it was a systemic collapse of the front-end load balancing service. For 1 hour and 44 minutes, the very pipes that carried data across the globe were choking. Thousands of users were hitting walls, and the scale of the impact was staggering as entire regions lost connectivity to essential cloud tools. Something deep within the core networking code had just tripped a landmine, and the fallout was moving fast. You don't just get an outage like this, you get a catastrophe. Picture this. It's a quiet morning in the data center, but for thousands of users across Europe, the world just went dark. On November 12, 2021, at exactly 9:30 U.S. Pacific, Google Cloud hit a massive wall. The issue wasn't a simple server crash. It was a fundamental failure in the front-end load balancing service. This wasn't just some minor glitch, it crippled critical infrastructure like Cloud Spanner and Bigtable, leaving websites across the continent throwing 404 errors instead of serving content. What made this particularly nasty was that a new infrastructure feature actually triggered a latent bug buried deep within the internal network load balancer code. It took about 1 hour and 44 minutes to fully stabilize the system by 02:14 U.S. Pacific. For those of us in the trenches, it's a textbook reminder of how hidden legacy code can become a landmine when new features are deployed without enough rigorous regression testing. It was a standard Tuesday for the infrastructure teams, just another day of keeping the gears grinding in the massive Google Cloud machine. Everything was humming along until November 12, 2021. The system was built to be robust, but beneath the surface, a new infrastructure feature had introduced a hidden instability, a latent bug lurking within the internal network load balancer code. It sat there silently for months, waiting for the right catalyst to wake it up. Then, at exactly 9:30 U.S. Pacific, that spark hit the powder keg. The front-end load balancing service began to buckle under the weight of its own logic. What started as a subtle glitch in the code quickly manifested into a widespread failure, threatening to sever connections for thousands of customers across Europe who relied on everything from Cloud Spanner to Bigtable. The storm was brewing, and it was about to hit the fan. Imagine the scene on the morning of November 12, 2021. At exactly 9:30 U.S. Pacific, a silent failure began to ripple through the infrastructure. It wasn't just a minor glitch. It was a systemic collapse of the front-end load balancing service. Suddenly, across regions, particularly in Europe, the digital lights started flickering out. Customers were staring at 404 errors as websites vanished and critical services like Cloud Spanner and Bigtable became unreachable. For the engineers on the front lines, the alarms weren't just metaphorical. They were witnessing a massive downstream impact where their core networking fabric was buckling. They had to move fast because the clock was ticking. While automated safety systems managed to catch the error within 4 minutes to slow its spread, the team still had a grueling 1 hour and 44 minutes of high-stakes troubleshooting ahead of them before the service was fully restored at 02:14 U.S. Pacific. It started with a ghost in the machine, a new infrastructure feature that poked a dormant, latent bug deep within the internal network load balancer code. At 9:30 U.S. Pacific on November 12, 2021, that hidden flaw finally tripped, and the front-end load balancing service began to buckle. It wasn't just a localized hiccup, it was a systemic collapse. The failure radiated outward like a shockwave, crippling critical services across multiple regions, with particularly heavy damage hitting Europe. Suddenly, everything downstream was screaming. Cloud Bigtable, Cloud Spanner, and the container registry all started failing. Users weren't just seeing lag, they were hitting walls of 404 errors as their websites and applications simply vanished from the web. It took the team roughly 1 hour and 44 minutes to wrestle the beast back into submission by disabling the faulty code path before the network finally stabilized at 0214 US Pacific. The root cause of this chaos wasn't a simple configuration typo, it was a ghost in the machine triggered by a new infrastructure feature. When that specific update rolled out, it inadvertently tripped a latent bug buried deep within the internal network load balancer code. This failure hit the front-end load balancing service directly, causing a massive ripple effect across multiple regions, especially throughout Europe. From Outage 30 to 0214 Pacific Time on November 12, 2021, this underlying code flaw caused systems like Cloud Spanner and Bigtable to buckle under the pressure. While automated safety systems managed to catch the spike and slow its spread within just 4 minutes, the core issue remained until engineers could identify the specific vulnerable path. The fix involved disabling that broken logic entirely, but it served as a stark reminder of how a single latent bug in a core component can bring down an entire global network infrastructure. When the front-end load balancing service buckled on November 12, 2021, it didn't just trip a local alarm, it sent shockwaves across the entire infrastructure. The blast radius was massive, hitting critical services like Cloud Bigtable, Cloud Spanner, and Container Registry. This wasn't just a minor glitch in a corner of the network, it crippled core functionality for customers across multiple regions, with particularly heavy impact reported throughout Europe. For those caught in the crossfire, websites and applications suddenly began throwing 404 errors, as traffic failed to route correctly. The chaos lasted roughly 1 hour and 44 minutes before the engineers could finally roll out a fix to disable the faulty code path. In that window, the sheer scale of the failure demonstrated how a single latent issue in a new feature can paralyze an entire ecosystem of downstream services simultaneously. Imagine the silence of a monitoring room suddenly shattered by a cascade of alerts. On November 12, 2021, at exactly 0:30 US Pacific, the front-end load balancing service began to buckle under the weight of a hidden flaw. It wasn't just a minor glitch, it was a systemic failure that rippled across Europe, knocking out critical services like Cloud Spanner and Bigtable while leaving customers staring at 404 errors. The engineers were fighting a ghost in the machine, a latent bug buried deep within the internal network load balancer code, suddenly awakened by a new infrastructure feature. While automated safety systems caught the spark and slowed the spread within just 4 minutes, the team still had to navigate the wreckage of a collapsing network. They moved with precision, identifying the compromised path and rolling out a fix to disable the vulnerable code. By 0214 US Pacific, the storm had passed, leaving behind a hard-won lesson on the dangers of hidden dependencies. The fix wasn't a magic wand, but it was surgical. Once the team identified that a new infrastructure feature had tripped a latent bug in the internal network load balancer code, they moved to isolate the damage. By rolling out a targeted update to disable that specific, vulnerable code path, they managed to stabilize the front-end load balancing service and halt the cascade of 404 errors. The entire ordeal was mitigated by 0214 US Pacific on November 12, 2021, ending a tense 1 hour and 44 minutes of chaos for users across Europe. But fixed doesn't mean forgotten. To ensure this ghost wouldn't haunt them again, the engineering team began implementing a permanent root cause fix designed to harden the system against latent issues triggered by future infrastructure changes. It was a hard-won victory in the trenches of global scale. The heavy weight of this incident lies in how a single, latent bug can sleep within the code for years only to be awakened by a new infrastructure feature. While automated safety systems did their job detecting the error and slowing its spread within just 4 minutes, the sheer scale of the impact across Europe proves that slow is still a crisis when it affects critical services like Cloud Spanner and Bigtable. The real takeaway here isn't just about how fast we can react, but how deeply we must audit our core systems. We learned that a temporary fix to disable a vulnerable code path is a necessary band-aid, but the true engineering victory lies in identifying and neutralizing those hidden risks before they can be triggered by future updates. To prevent another collapse of the front-end load balancing service, the team must move beyond hotfixes toward permanent architectural remediations that ensure latent issues don't become active landmines for our customers. That's how Google Cloud turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.